is the first part of the second half of chapter 8, and you're going to notice that there are two standards we're going to be looking at: graphing exponential equations and solving real-world explanation problems. You're going to notice that our graphs aren't straight lines anymore. They kind of have a J look to them, or an L look to them. But this will be the next section that we're going to be studying. So first of all, where do we see exponents and why are they important to us? Of course, we see them, you know, in math, and we see them in science. We see exponents with money. We see them with big numbers. We see them with small numbers. We see them in the newspapers. We see them in the news, magazines. We see them a lot of places. All right, what I want you to do right now is I would like you to take out a sheet of paper. I wouldn't have it in your notes. I'd have it like notebook paper, right? And if I take a look at this, you're going to notice that there is one rectangle. There's one rectangle. And if you look at it, how many folds do we have right now in our rectangle? We have 0, right? We have 0 folds. Now, what we're going to do is we're going to leave the pattern blank, and we're going to leave the exponents blank for right now, right? And we're going to go to the next line. What I want you to do now is I want you to take that piece of paper, and it doesn't matter if you fold it like a taco or a hot dog, just make a fold in it, right? Open it up, and you're going to notice that your paper's been cut into 2 rectangles, right? And if you take a look at the 2 rectangles, right, the pattern is 2, or I can write it as 2 to the first. And you're going to kind of see the pattern as we go, right? Now what I want you to do is I want you to take this same piece of paper, and we're going to fold it again. And you can fold it again like a hot dog or like a taco. You're going to be folding it in half each time. And if you open it up, you're going to notice that we have 4 rectangles. All right, and that can be written as 2 times 2 or 2 squared. Let's keep going. I'm going to take the same piece of paper, right? I'm going to fold it, and before we open it up, how many rectangles do you think we're going to have? Think to yourself how many that's going to be. Take your piece of paper and open it up, and you're going to notice that there should be 8 rectangles, and I can write it as 2 times 2 times 2, or just 2 to the third. Okay. We're going to keep going. I'm going to take this same piece of paper, and I'm going to fold it in half again. How many rectangles do you think we're going to have? Okay. Open it up. Notice that we have 16. And that can be written as 2 times 2 times 2 times 2, or 2 to the 4th. Notice the 2 to the 4th. It's easier. It's easier to deal with, right? Then finally, fold it again. Think to yourself, how many rectangles will I have? Open it up and count it. And you're going to notice that we have 32 rectangles. And that, of course, can be written as 2 times 2 times 2 times 2 times 2, or 2 to the 5th. 5 being the number of folds. Okay, so I can take a number and I can use it with exponents to help me decide the future. All right. Let's go to the next slide. Now we're going to use another scenario with exponents. Let's look at how it can be used in real life. So suppose there are 20 rabbits on an island, and the rabbit population, it triples. Okay, it triples every half year. And they want to know how many rabbits will there be in 2 years. Now this is where exponents can help us. Exponential growth, exponential decay. I have this number of rabbits, and then I get more rabbits and more and more. And you can see where population can become a problem for a country, or too many rabbits, too many cats, too many dogs. Why do we have to have them spayed and neutered? Why do you think that would become an issue? So you can see where some of those issues come to play in math. So what we're going to do is, first of all, the time is initial. That means starting. That means we're at the start. All right, and I've got 20 rabbits, and I can write it as 20 times 3 to the 0. 3 because it triples, to the 0 because 0 time has taken place. Right? Now let's go to a half a year. You're going to notice that's 6 months. I'm going to triple it, so that's why I get that 3 there. 20 times 3 then is 60, and I can also write it as 20 times 3 to the first power, because one triple has taken place. Right? Let's go on then. I've got a half a year down. I'm going to go to 1 year. Right? That's 6 months later. I'm going to take 20 times 3 from up above, and I'm going to multiply by 3 again. Right? And you're going to notice that that's 20 times 3 to the second. Right? And if I do the math, I end up with 180 rabbits. Wow, that's a lot of rabbits. Now, we're not taking into account that, you know, we have triplets amongst the litter. We're not taking that into account. We're also not taking into account that some of the rabbits died. We're just saying that it's just basic population. Right? All right, so 1 year went by. How about a year and a half? Let's take a look at this. So a year and a half, 6 months goes by. Again, I'm going to take 20 times 3 times 3, and then I'm going to multiply by 3 again because it tripled. Okay, so it's 20 times 3 to the third. And if I do that, we end up with 540 rabbits. A lot of rabbits. Okay. Now we got to go 6 more months. So of course that gets us to our 2-year mark. We're going to write it as 20 times 3 times 3 times 3 times 3. Okay, which of course is a lot to write down. That's why exponents are so helpful. It's 3 to the 4th because there's 4 3s. And if I do that and multiply 540 then by 3 because it tripled, I end up with 1,620 rabbits. Okay, so there's 1,620 rabbits, which of course can cause a problem. Let's move on. We're going to evaluate each function when the domain is. Now, we have done this with linear already. What's different with this is you're going to notice the equation looks a little bit different. It's y equals, which we're used to, but it's 3 to the x. You'll notice the x is an exponent, and we haven't had that before. When you do these, what you're going to do is you're going to make your h table like you did in the past. And you're going to put your x in the first column. You're going to go y equals 3 to the x. Make sure your exponent is small and to the right. And we're going to put our y in the last column, right? Now, they say the domain, just like linear, it's going to be your x. And we're going to try to find our y. So what we're going to do is we're going to plug in the numbers they told us to. So we're going to put in a 0. Y equals 3 to the 0. And remember, anything to the 0 power is 1. I'm going to draw a line, just like we did with our linear. I'm going to put in a 1. Y equals 3 to the 1. 3 to the 1 then is 3. Draw my line. Put in a 2. Y equals 3 to the second power. You'll notice that it's 9, right? So you show your work very similar to what we did in the linear equations, but this is going to look a little bit different. Now, when they ask us to evaluate, remember that means solve. And so you'll notice the domain was given to you a certain way. You need to make sure that your range is also given to you a certain way. So it's 1, 3, 9. You need to make sure it's in that order. Again, very similar to the linear equations. It's just rather than a linear equation, it's exponential. All right. Now we're going to get something like this. Notice it asks me to graph. And so what I'm going to do is I'm going to use my H table that I have here. I'm going to put in my x, y equals 2 times 3 to the x, and I get the y. Now, every time you graph, you need to come up with a table like this. If I don't have the table and I don't have the work, I'm not going to accept it. So make sure that you do it, right? Now, you'll notice they don't give me the domain. So if you remember with linear, when they didn't give me the domain, I could choose the numbers that I wanted to. We're going to choose those numbers again. We're going to choose -1. So y equals 2 times 3 to the -1. It's a two-step equation, so I'm going to show my work. Y equals 2 times, now I got 3 to the -1. If you remember, we talked about this before. If it's to a negative exponent, remember, it doesn't like where it's at, so it goes down below and it becomes a fraction. So the 3 goes down below and becomes a 1 in the numerator then. So then 2 times 1/3 ends up being 2/3. Right? Then I'm going to plug in a 0, which I've talked about before. Y equals 2 times 3 to the 0. Y equals 2 times 3 to the 0, or anything to the 0 power, is 1. So 2 times 1 then is 2. And finally, I'm going to plug in a 1. So y equals 2 times 3 to the 1. Y then equals 2 times 3, and I get 6, right? You need to plug in 3 for sure. Eventually, you may have to plug in more, but right now, that's what we're going to plug in. Now, I've got my x and y axes, just like I did for linear. I'm going to plug in -1 and then 2/3. 2/3 is between 0 and 1, all right? So when you do this, you know, you have to be a little bit careful. It's right there, right? And remember, I have graph paper at the back of my room, so feel free to use that. The next one is 0, 2. So 0, 2 is right there. And the last one is 1, 6. So 1, 6. Now you'll notice that this really isn't a straight line. In fact, what happens is it's kind of a J shape. So when you draw these, be really, really, really careful. You're never going to cross the x-axis for us. It's going to get closer and closer and closer to the x-axis, but it will never totally cross the x-axis. So this is kind of what it's going to look like. It's going to start close to the y-axis, and it's going to go through those lines. Okay? So it's going to get really, really, really close to it, but it's never going to totally cross that x-axis for our purposes, right? And you're going to notice that this is going up, so it's considered a growth. Right? So I graphed it. I plugged in -1, 0, and 1. Now, when you do your assignment for me, you're going to be graphing these. They should not form a straight line because it's not a linear equation. It's not in the form y equals mx plus b. The exponent has a variable, so it's going to look a little bit different, and make sure the graph reflects that. Also, make sure you plug in a negative number, you plug in 0, and then you plug in the positive.